Welcome to the deep dive. Today we are strapping in for what might be the fastest revolution happening in aerospace right now.
It really is.
We're talking about vertical lift, and specifically how commercial electric vertical takeoff and landing technology, or eVTOL, is merging with global defense needs.
And at a pace that is, well, genuinely unprecedented.
Yeah, it's the ultimate contrast in timelines, isn't it?
Oh, absolutely. For decades, the gold standard for military procurement was these, massive multi-decade cycles. Just look at the Army's Future Vertical Lift Program, FVL.
FVL, right. That started way back in 2009.
2009. And its goal was to replace helicopters like the Black Hawk and Apache, which were designed back in the 60s and 70s.
So you're looking at a replacement cycle that's, what, 20, maybe 30 years long?
At least. It feels less like buying a new plane and more like a generational project.
Exactly. And so in contrast to that almost glacial pace, we're now seeing commercial aviation just deliver warfighting capability right now.
Driven by private capital and high-speed iteration. Which is why our mission for this deep dive is to look at two huge recent announcements. One from Anduril, one from Joby.
And these really show a fundamental shift, right, towards hybrid electric power, smart autonomous software, and these new global manufacturing partnerships.
So the real questions are, what are the specific innovations making this happen?
The hybrid power, the AI command platforms.
Right. And what does all this speed mean for the sheer cost of military power?
Are we witnessing the end of the trillion-dollar weapons platform?
That is the key question.
Okay, let's unpack this. We should start with that powerhouse collaboration announced just recently, November 13th, 2025, the Eddie G. Anduril Production Alliance.
And this isn't just some commercial contract. This is a full-scale defense technology partnership aimed squarely at markets in the Middle East.
The money involved is, well, it's staggering.
It really is. It shows how serious they are. You have the UAE's Eddie G Group pouring in $200 million.
And that's on top of the $850 million that Anduril has already invested internally on VTOL development.
Exactly. And the whole thing is anchored around one aircraft, the Omen drone.
Okay, let's get into the Omen's design, because this is where the engineering gets really interesting. It's described as a breakthrough. It's a hybrid electric tail-sitter VTOL, and it stands about 10 feet tall. For those of us who aren't engineers, what exactly is a tail-sitter, and why is that so significant?
A tail-sitter is, well, it's pretty much what it sounds like. It takes off and lands vertically, just resting on its tail. Think of it like a small rocket standing up.
So it launches straight up.
Straight up, using electric motors for lift. But then, once it's in the air, it pitches over 90 degrees and flies horizontally like a plane. It uses these long, very efficient sailplane-style wings.
That sounds incredibly unstable, especially that transition part.
It is a massive flight control challenge, a huge one. And that's why it needs the kind of advanced autonomous software we'll get into later.
But the payoff is worth it, I assume.
Totally worth it. You completely remove the need for a runway. And it minimizes the footprint you need for operation, for storage.
Which is critical for being able to disperse your forces and stay resilient in the field.
Exactly.
Now, they hit a wall, didn't they? With the endurance, using just pure electric power. It's a common problem for eVTOLs. How'd they solve it?
They pivoted to something called series hybrid technology. You can think of it like a hybrid car, maybe a Chevy Volt.
Okay.
The combustion engine doesn't directly drive the propeller. Instead, it just acts as a generator. It's constantly recharging the batteries that power the electric motors.
And that breakthrough came from a partnership with Archer Aviation, right? The commercial eVTOL developer.
That's right. Back in December 2024, that partnership sealed the deal.
So the commercial sector, Archer, brings the power solution, and Anduril integrates it into a defense platform, Omen, that can actually fly from military-relevant times.
It's the perfect collaborative bridge. And performance-wise, this thing is a heavy lifter. Omen is a Group 3 aircraft.
And Group 3 normally means what, 55 pounds up to around 1,300 pounds?
Yeah, but they usually only carry really lightweight surveillance gear, maybe 25, 50 pounds max.
So about the weight of a standard delivery drone package.
Right. But Omen's design lets it carry 3 to 5 times more than that.
Wow.
And that expanded capability is why Anduril sees it as so disruptive. It's not about replacing other small drones. It's about doing the job of much, much bigger systems.
And that disruption also extends to the manufacturing side of things.
Yeah.
This isn't some slow, U.S.-only factory process.
Not at all. We're talking about a global production base built for volume. The UAE already committed to buying the first 50 Omen systems.
And that anchors a new factory, a 50,000 square foot facility in Abu Dhabi.
While at the same time, U.S. orders will be built at Anduril's Arsenal 1 facility in Columbus, Ohio.
So they're building on 2 continents at once.
And the goal is full-rate production of mission-ready systems by the end of 2028. That rapid multi-continental scaling it's the core of their hyperscale philosophy.
The hardware is one thing, but with any autonomous system, the software is where the real capability is. Omen uses Anduril's Lattice platform.
Yes.
So how does that AI system translate into an actual advantage on the battlefield?
Well, the fascinating thing here is that Lattice goes way beyond just remote piloting. It's an AI-powered command and control system. It manages the mission autonomously.
Meaning one operator can handle multiple aircraft.
Exactly. We are talking about true drone swarm operations.
So paint me a picture of that in action.
Okay, imagine a squadron of, say, 6 Omen drones on a maritime surveillance mission. One of them detects something unexpected, like a submarine contact.
Okay.
Lattice instantly coordinates the others. It redirects their flight paths, reassigns their sensors, shares targeting data across the whole group. It adapts to the threat in real time.
Like a hive mind. No constant human joysticking required.
A cohesive distributed network.
Precisely. And the physical design, being runway independent, supports that simplicity. How easy is it to actually deploy in the middle of nowhere?
It's designed for exactly that, extreme expeditionary operations. A 2-person team can transport it, assemble the 10-foot aircraft, and launch it in just minutes.
No special infrastructure needed.
None. And that is a total game changer for contested areas, especially in places like the Indo-Pacific, where big, fixed bases are just giant targets.
Which brings us back to the economic argument. If they're cheaper, faster to build, easier to use, they really do shake things up.
They absolutely do. Anduril has been explicit about this. Their goal is, and I'm quoting here, disrupting current maritime patrol special mission aircraft, much bigger systems.
So they're not even worried about other Group 3 drones.
Not at all. They're aiming at platforms that cost tens of millions of dollars, maybe even $50 million a pop. They want to deliver that same capability for a fraction of the cost.
And the modular design helps that model by bringing in more customers, and not just military ones.
It's critical. You have military roles like maritime awareness, electronic warfare, but the modularity means you can easily switch to civilian roles, like acting as a flying cell tower, an airborne telecom node during a disaster, or even just light resupply for remote communities.
So that dual-use approach creates what you call a commercial flywheel.
It does. Higher commercial volume drives down the unit cost, which in turn makes the military version cheaper and easier to field.
That's the perfect setup for our next big announcement. Let's pivot to Joby Aviation,
the commercial leader in the eVTOL space.
and their very rapid move into defense with their partner, L3 Harris.
This is just a perfect demonstration of speed. I mean, Joby already had the world's most tested commercial eVTOL, the S4 Air Taxi.
Right, that's one that's logged over 50,000 miles of flight testing.
But they knew that to meet military needs, they couldn't just rely on batteries alone.
So they adapted it. They integrated a hybrid turbine powertrain and their autonomy system, Superpilot.
And the speed is what gets me. The first flight of this hybrid version was November 7th, 2025.
Just 3 months. 3. After the partnership with L3 Harris was even announced back in August.
That's startup velocity applied to a military-grade aircraft. It's incredible.
But wait, isn't Joby kind of compromising its all-electric vision by adding a turbine engine? Is this a necessary evil until batteries get better?
It's an absolutely necessary bridge. Look, pure electric is great for short hops, flying across a city.
Urban air mobility.
Right, but it just can't deliver the range, the payload, and especially the extended hold times that military missions demand.
The ability to just loiter over an area for hours.
Exactly. The Air Force has been very clear that this is a current limitation for pure electric platforms. The hybrid system solves that problem today.
So the hybrid is what unlocks the military market.
Yeah.
And L3 Harris's role is missionization, turning that commercial airframe into a weapon system.
Yep. They're focused on equipping it for things like contested logistics, moving critical supplies into dangerous areas, loyal wingman operations, counter-UAS, electronic warfare.
A whole suite of missions. And Joby, they've already done the hard work on the autonomy side with their Superpilot system.
Oh yeah, Superpilot is not theoretical. They've been developing and testing it for over 5 years.
I remember reading about the Re4Pack exercise.
A key validation point. During that exercise, they logged over 7,000 miles of autonomous operations in the Pacific, using a conventional aircraft with their system on board.
Which proves the system can handle complex, long-distance missions.
And the government is backing this specific trend with real money. Mission demos with Joby's hybrid aircraft are set to begin in 2026.
And the overall budget signals that the demand is there.
Massive demand. The U.S. government requested over $9 billion in the FY26 budget for next-gen platforms, and they specifically called out resilient, autonomous, and hybrid aircraft.
They are voting with their dollars.
Absolutely.
So if we connect the dots here between Anduril and Joby, the main takeaway seems undeniable. Hybrid electric power is the new essential standard, at least for now.
It's the pragmatic reality. It is the only validated path right now to get military-relevant endurance while we wait for that big breakthrough in battery energy density. It's a smart way to de-risk the whole thing.
And you can see how this speed is affecting the competition. Other companies, like Archer, are now strategically partnering with defense primes like Anduril.
And some analysts view that as a scramble to keep pace. Joby had an early lead in the commercial space, so others are using defense contracts to catch up. The race is fierce.
And the contrast with the old way of doing things is it's stark. You mentioned the Army's FVL program isn't expecting operational aircraft until the early 2030s.
The early 2030s?
That timeline feels like planning a major home renovation that you won't start for another 20 years.
It does, and you contrast that with Joby going from a partnership announcement to a first flight in 3 months, or Anduril building this global production network, Ohio, the UAE, possibly Sydney and Wales, with operational targets for 2028.
It's a new philosophy. Hyperscale manufacturing for defense.
Exactly.
So the trend is clear. Defense innovation is now measured not by how much you spend, but by the sheer pace at which you can turn a commercial idea into a fielded capability.
And they are just completely bypassing those decades-long procurement cycles.
Which creates that dual-use flywheel effect. Commercial development leads to higher production volume, which lowers the unit cost, which makes the military systems more affordable.
And potentially more expendable. It's a revolution in military economics.
It's an aggressive and globally distributed shift, though. Both of these big alliances involve U.S. and foreign partners. They need a ton of government approvals, export controls.
And that's where you get friction.
Right. So considering this aggressive global scaling and the fact these AI-powered systems are designed to proliferate quickly, the provocative thought we want to leave you with is this.
How can traditional government trade regulations, which were designed for slow-moving, single-site military hardware, possibly adapt?
How can they manage the rapid spread of this dual-use autonomous VTOL tech across a new global factory network? It feels like a regulatory challenge that's already falling behind the technology.
Something to mull over as you watch this new era of vertical lift really take flight.
Thanks for diving deep with us. We'll catch you next time.